Okay, so I'm going to start with 1. And says for the following normal chromosome is letters with L and R U V chromosome, letters M N centromere O P Q V E R W X. And alleles present are the centromeres indicated with a little dot. And then it says, suppose that these 2 chromosomes replicate prior to meiosis, pursue 4 total sister chromatids. The 2 replicated chromosomes then attempt to synapse during prophase 1. What is the allele and centromere composition of the products of meiosis if there's a crossover between S and T? So to do this problem, we set up this little diagram right here, and the little line down is between the normal one on the top, the bottom 2 is the inversion one. And to do this, product 1 would be the normal one, and then product 4 would be the inversion. And so to get product 2 and 3, you're gonna, and so product 2 would be X lowercase XWRS with a uppercase of TUVWX, and then product 3 would be uppercase LMN centromere OPQRST, lowercase TUVQPO centromere NML. So again, product 1 is the normal, product 2 is lowercase XWRST and then uppercase TUVWX. Product 3 is uppercase LMN centromere OPQRST with lowercase TUVQPO centromere NML, and product 4 is the inversion.
Okay, so for number 2, A says non-disjunction in meiosis 2 produces 50% aneuploid gametes, whereas disjunction in mitotic can produce a mosaic phenotype. For B, for the meiosis, an individual who has suffered paracentric inversion produces a dicentric chromosome and an acentric chromosome, so it's paracentric inversion. C, the first one is Turner syndrome. It's an example of a human disease caused by monosomy, while familial Down syndrome is the example of a disease caused by Robertsonian translocation. It's the human liver cell that can be 4N, 8N, or 16N. Deletion in chromosome 5 causes the Cry-Duchenne syndrome, while an inversion on the X chromosome causes type A hemophilia. For F, we got gene duplication is a change in chromosome structure that can be potentially beneficial to an organism or an entire species. It says when a translocation is formed, a alternate segregation pattern can produce viable gametes and offspring. I actually stopped.
Okay, so I've got problem number 3, and in the first part of it, look at my computer back here. is the total chromosomes for the following syndromes. So Turner syndrome has 45 because it loses an X chromosome. Jacob syndrome has 47 because it adds an X chromosome in a male. The French one that no one can say, but we call it Cru de Chat syndrome, is 46 because no chromosomes are lost. It's just a deletion of part of an arm. And then familial Down syndrome has 47 because one chromosome is duplicated, but then there's a translocation with another chromosome, and so they fuse together. And then type A hemophilia, 6 because it's just an inversion, so no chromosomes are added or gained, or lost or gained. And then for B, which of the following terms is not associated with Charcot-Marie tooth disease? And we put triploid, aneuploid, reciprocal translocation, and non-disjunction are not associated with that disease. And then C, which are associated with Klinefelter syndrome. We put aneuploid, trisomy, and non-disjunction. And then number D, what are associated with type A hemophilia? We said none of them because it's just an inversion.
All right. For number 4, diagram. First question is to diagram the synapse of the chromosomes in prophase 1. So we know in prophase 1 is where crossing over occurs. So this is my prophase 1 crossing over diagram right here. You can kind of see the one chromosome is taking that other piece and applying it to the other one. And then identify the allele composition of gametes produced by alternate segregation. So alternate segregation is where you have 4 chromosomes. You're one that didn't cross over, and then 2 that did cross over, and then another one that did not cross over. And I kind of diagram those right there, like we can see in the slides in that one example. And so for B, identify all the gametes produced by alternate segregation. This is where the 2 that didn't cross over pair up, and the 2 that did cross over pair up. So the first cell would have D, E, F, G, H, centromere I, J, K, L, would be paired with M, N, O, P, centromere Q, R, S, T. The second cell would have M, N, O, G, H, centromere I, J, K, L, paired with D, E, F, P, centromere Q, R, S, T. For C, identify the allele composition of gametes produced by adjacent 1 segregation. Adjacent 1 segregation is where the centromere that is normal pairs with the one that did cross over in the other centromere or chromosome. So you got a normal and then a crossover, and it's the crossover from the other one. It doesn't go with the one that it already had. So for the first cell, it's D, E, F, G, H, centromere I, J, K, L, paired with D, E, F, P, centromere Q, R, S, T. Second cell is M, N, O, G, H, centromere I, J, K, L, paired with M, N, O, P, centromere Q, R, S, T. And then for adjacent 2 is where they take the ones they originally paired with. So the normal is already paired with the one that crossed over, and it just takes that one and leaves, and the bottom 2 that were already together are again paired. And this doesn't happen very often. That's adjacent 2 segregation. So that one, you can kind of see I wrote those out right there. I'll just read them as well. The second one, the first cell would have D, E, F, G, H, centromere I, J, K, L, would be paired with M, N, O, G, H, centromere I, J, K, L. And then
we can talk about, like, it says how much you collected.
the second one would be D, E, F, P, centromere Q, R, S, T, paired with M, N, O, P, centromere Q, R, S, T.
Okay. That's working.
Yeah.
Okay. So for number 5, this one, it has a total of 38 chromosomes, and the A is asking if it was a triploid cat, how many chromosomes would be found. So you take 38 divided by 2, which gives you n, and then multiply it by 3. So you have a total of 57. B is monosomic for chromosome 12, and it's 37 chromosomes because you lose 1. C, a cat that has suffered terminal deletion on chromosome 7 has 38 because it's a loss of an arm, not the whole chromosome. D, a cat that has suffered a Robertsonian translocation between chromosome 17 and 18, we put 37 because the 2 chromosomes fuse together. And E, a cat that has suffered a reciprocal translocation between chromosomes 6 and 9, we have 38 because they're just exchanging pieces, not adding or subtracting.
We good?
I think so.
Okay.